Hello, everyone. I wanted to just create a quick video describing how to analyze the Pasco Capstone file that I created that contains the information from a vertical jump. So if you need to analyze this offline, if you're not able to attend class, if there's a snowstorm, that sort of thing, then you can analyze this particular video that you can download from Brightspace. Okay, so to open the video, open up your Pasco Capstone and then go to File, Open Experiment. And then we're going to choose this one, Jump File Spring 2024. So double click on it. Takes a second to load. And then to see the actual graphs, you're going to use this icon right here. So it says allow simultaneously viewing of multiple data sets. If we click on the arrow, we can choose what graph we want to look at. So let's look at body weight first, because remember, the first thing you have to do is you have to figure out the body weight of the person. So if I click on that, it looks like right now it's zoomed in. So I can change the scale on the y-axis here. Let me double click on the bottom number and change that to a 0. So the minimum axis value will be a 0. I'll hit OK. And then I'll change the top number to maybe like 1,000 or something, just so I can see this better. And the actual body weight will look like it's, horizontal, pretty much flat. Okay, so then remember, to get this thing right here, let me delete it so I can go back to it. You have to use this yellow icon here, which will allow you to like select different parts of the graph, and you can resize this however you want. So for this part, basically you're just finding a location where the body weight is pretty much constant. And then we want to find the average, right, in this region that you highlighted. So to do that, you just click on the sigma button. Okay, and it'll give you the mean here, which is going to be the average body weight in newtons, right? So you'll need that value first. Okay, once you have that value, then again, you want to make sure you watch my other video because I describe all of this carefully. But once you have that value, you can calculate the mass of the person by basically dividing by g, right? Because W equals n times g. So the mass is going to be the weight in newtons divided by g, divided by 9.8. All right, once you've done that, then the person, if you were attending the actual lab, the person would perform the counter movement jump. So let's look at that graph. So I'm going to go back over here to this arrow. I'm going to click off body weight and then click on counter movement jump. So it looks something like this. Now, again, when we did this, remember this now is detecting the force plate is detecting the net force acting on the person. So this graph is the net force versus time. And the way that we got the net force was we basically tared the force plate, we zeroed it when the student was standing on the force plate. So effectively, we subtract out the body weight. Because remember, the net force is going to be the normal force, the ground reaction force, which is really the normal force, minus the body weight. So by tearing it, we've effectively subtracted out the body weight. So at first, if the person's just standing still, this region right here, they're just standing still, the net force is going to be 0 newtons, right? Here's where they do the counter movement. And then this part right here, right, basically this is like negative their body weight, this region. This is when they're in the air. So remember, the first thing you have to analyze is you have to figure out the time that the individual is in the air. That's one way that we're going to calculate the jump height. So you can kind of zoom in here. I'm going to shift this over. And then if I use the x-axis, see how I have like a double arrow here? I can like lengthen this to make it wider. So I'm kind of zooming into this part right here that I want to analyze. So I want to figure out the total time that the individual is in the air. Okay, so we can use this tool. Again, let me delete it and then show you how I got that tool. Remember, if you go to coordinate tool icon here, and then if you click on add multi-coordinate tools, you can drag this to right when they leave the force platform, which is like right around here somewhere, maybe like right there. Record that value, so that'll be the initial time. And then when they land again, right before the force goes up, maybe right there, record that time. And then the difference, if you subtract those, that's going to be the time of flight. Okay. So you're going to need that information, and then that will allow you to calculate the jump height using time of flight. All right. Let me get rid of this. Now we need to figure out the impulse, because we want to use the second method of getting the jump height using the impulse momentum method, right? So I'm going to zoom back out here. Actually, let me do this. I want to get just the part where they're doing the counter movement. I want to find the impulse when they're doing the counter movement. I'm going to shrink that back a little bit. Okay, so that's this part. Starting somewhere here, right, where the net force is 0, I want to find this area where it's negative, positive, and then a slight sliver of negative here. I'm going to find the area from here, like underneath the curve, from here to right when the person leaves. So again, I'm going to use this icon right here, right? Highlight range of points and active data. I'm going to change the size of it so I encompass exactly the area that I want to calculate, which is, again, from 0, somewhere around 0, doesn't have to be anywhere in particular, like right where it starts, right around 0. And then the right-hand side is going to go to right when the person leaves the forest platform, which is maybe right there. Okay, so to find this area underneath, remember, it's always with respect to the time axis. So it'll be like this negative, this positive, maybe a little bit of negative here, this positive, and then the sliver of negative here. You simply click on this icon right here. This is display the area under highlighted data. And that value, so in this case, the 143.89 Newton seconds, that's going to be the impulse. Okay, so that will allow you to calculate the jump height, right? First of all, it'll allow you to figure out the takeoff velocity, and then once you have the takeoff velocity, you can calculate the jump height. All right, and then the same thing with the squat jump, right? So if you go to the last graph here, squat jump, now there is no counter movement. There's no negative here. It's just positive, right? I'm starting in a squat position at rest, right? So my net force is 0, and then I'm just pushing off, pushing positive, and go through the jump. So same thing. You guys are going to have to find the time of flight. So you're going to have to find the time from here to here, the time that the person's in the air. That will allow you to calculate the jump height using time of flight. And then you need to calculate the impulse, right, when you're doing the squat jump. So again, that will be, expand this out a little bit. That'll be from 0. So anywhere over here, it doesn't really matter where you start, as long as that's 0. Make sure you include the entire graph. And then the right-hand side is right when they take off from the platform, something like that. Okay, and then I'm going to click this area button, and that'll give me the impulse for the squat jump. Again, that will allow you to calculate the takeoff velocity, and then once you have the takeoff velocity, you can compute the jump height. Okay, so if we have a snow day or something, then you can use this data set. You don't have to collect any data. You can use this data set to work on your group lab reports. All right, thanks.